All right, we've waited a good minute to let folks come in and get settled. Good morning and welcome to the Coastside Land Trust Community Webinar Series. Our goal with this series is to bring together a diversity of environmental perspectives to help us better understand the world and our role in caring for it, both locally and globally. And we at the Coastside Land Trust here, our mission is dedication to protecting the open spaces that define our coastline, and that's from Half Moon Bay to Montera, so they remain preserved for future generations. We focus on safeguarding scenic bluffs, stream corridors, and agricultural lands through land protection, conservation easements, and restoration projects. Our work also supports local landowners and conservation funding and community education, but most importantly, our community is at the heart of all that we do. Whether you have the bandwidth to donate or volunteer or help spread the word, your support helps us protect the land we love. And we hope that we in turn can help for you to feel more connected to it. Couple of ground rules today is that we will have a Q&A section. So I'm about to introduce our presenter. I'm really excited to introduce our presenter. But we will ask that if you have questions today, just type those into the Q&A section. And at the end of our talk, Dr. Gary Griggs will be getting a chance to answer some of those questions. That said, today we are really excited to welcome you to Coastal Erosion and a Geology Talk with Dr. Gary Griggs. He is a distinguished professor of Earth and Planetary Sciences at the University of California, Santa Cruz, where he's taught for over 5 decades, 50, did you say 58 or 59 years and as a professor of coastal processes, hazards, and sea level rise. He's authored numerous books when he will give you a little glimpse of those at the end. If many of you, I think, are probably familiar, and we will link those in our follow-up email afterwards. So if you're interested in those, I have a number of those, both for adults and for children. Would love for you to take a look at those. He is widely recognized for his expertise in coastal geology, shoreline erosion, and the impacts of climate change. He also co-writes the popular Our Ocean Backyard column with his wife, and he has been honored as one of California's coastal heroes for his contributions to science and public outreach. So please join me in welcoming Dr. Gary Griggs. Gary, you ready to go?
Ready.
Okay.
The mode I have it in, I can't see anybody else. My full screen is the picture, so
That's all we want to see. So we're
okay.
good.
You don't want to see me.
We just want to see you.
Okay, so we're ready to go?
We're ready to go.
Okay. And first, thanks everybody for taking part of your Saturday to take part in this. And I guess I could probably use this one image, which is specific, which really embodies the title of the talk, Extreme Events, Sea Level Rise, California's Coast, and the challenge we have. So this will come up later. But around the world today, most of the world's big cities are on coasts for some obvious reasons. And a lot of the population sits on coastlines. So that presents some problems. One of the big one is sea level is rising globally. This isn't controversial. Well, it may be for some people. We know it's rising. We know the rate it's rising. And on top of sea level rising, we now have pretty good evidence that waves are getting larger. When you put those two things together, they are going to impinge on and impact our coast, whether it's villages or little cities or mega cities. This happens to be Venice, which is, one of the better sort of publicized areas where sea levels become a big problem. But locally, the Embarcadero in San Francisco at a really high tide is flooded, and you can see, what's behind that is an entire city, and this is with no additional sea level rise, but just a very high tide. It's not just us. The East Coast, this happens to be Miami, and the words up here are we can add one more thing to our list of life's inevitables, which is a rising sea level. I don't know, I just love this picture, and I'm trying to figure out what he's doing. These parking machines are complicated, but he's trying to find, I think, a place to put his boat, actually, for a while. But different problems in Miami than we have in San Francisco. So one of the things that's become increasingly clear is the planet's getting warmer. And this just goes back to 1940 or so, but the baseline at the bottom is the average from 1850 to 1900. So that tells you sort of what it was in the last century. And these are then average annual temperatures each year going up to 2025. So you can see it's getting warmer pretty regularly. There are some, differences from year to year. 2024 was the warmest year ever, but 2026 is on a path to probably be greater than that. We keep reading about a big El Nino on the way, so that will affect the shoreline. So as the planet gets warmer, two things are happening. Ocean water expands as it warms, like it does in your water heater, and ice melts. And that meltwater flows into the ocean, and all ice melts at 32 degrees Fahrenheit. It doesn't matter if you're a Democrat or Republican. So this is happening at an increasingly more rapid rate. Um, I sometimes ask my classes a question here. So there's three sort of areas of ice on the planet that are melting. The lower left is Antarctica. And I ask people, well, I'm sorry, the lower left is all the continental glaciers, the Alps, the Andes, the Himalayas. How much sea level would rise if we melted all that? And that's mostly melted, but about 2 feet. The upper right is Antarctica. And if we melted all of Antarctica, we'd raise sea level about another 24 feet. And on the upper left is Antarctica. That's where most of the ice is. If we melted all of Antarctica, we'd have about 190 additional feet. So around the planet, we have the equivalent of 216 feet of sea level rise if that ice melted. And one question I often ask audiences, are you at 216 feet or lower? Well, this is not going to happen this year or this century or next. Um, there has been periods of time in Earth history when all the ice melted, called it hothouse Earth, for under conditions that humans had no impact on. Um, but we don't need 216 feet. 5 feet, 8 feet is going to spell disaster for coastal areas around the planet. So someone did a graphic, I think, that's interesting. And this is just looking at California. For some reason, they used 218 feet, which is fine. What would be left above sea level? And they have some interesting labels here, like San Francisco Island and Marin Island and so forth. So this is the potential if all that ice melted, if it ever were to happen. So throughout geologic time, the Earth has warmed and cooled. We'll talk in a second about why. So as it gets warmer, ice melts, ocean water expands, and sea level rises. When it gets cooler, we sequester some of that ocean water as uh, ice sheets and glaciers. So if you look at this plot, it's actually from today on the far left to about 375,000 years ago on the right. So we can see sea level has gone up and down over about 400 feet. And if you look about 20,000 years ago at the end of the last ice age, sea level was about 400 feet lower than today. And then it rose to today. But that red dashed line along the top is what we call sea level today, zero. But if we'd been around and there were humans around any other time, 20,000 years ago, sea level would have been 400 feet lower. And we could have walked at, say, San Francisco, we could have walked out to the Farallones, which were dry land. Um, but you can see in the past, there were times when sea level was higher than today, 250,000 years ago, 200,000 years ago, 20 or 30 feet higher than today. So that would have made life very different. So why did this happen? Well, let me go back. This is just the last 24,000 years. 20,000 years ago, sea level, well, we were at the end of the last ice age. Sea level was about 400 feet lower. Again, we could have walked to the Farallones. It would have been a 30-mile hike. Um, but we had taken about 10 million cubic miles of ocean, about 3% of the ocean, and put it on land as ice sheets and glaciers. Much of the northern hemisphere was covered in ice. Uh, Gradually, beginning about 20,000 years ago, began to warm so that ice melted. And this is sort of the path of sea level as it rose. So from about 18,000 years ago to maybe 7 or 8,000 years ago, sea level rose fairly rapidly at a rate of about half an inch a year. Uh, Within that, we now are pretty certain that there were periods when it rose very rapidly, maybe an inch a year or 8 feet per century. We could almost watch that. And those episodes of rapid rise, we believe, were probably due to collapse of the Antarctic ice sheet. And there's people down there now studying that. What's happening beneath the ice? And this is a concern because it could rise much more rapidly than it is today. About 7 or 8,000 years ago, silver ice slowed to very, very low, less than a millimeter a year. And now it's increasing again. Over the last decade, it's been rising at about 3.8 millimeters a year or 15 inches per century. But that's accelerating. And the question is, where is it going to be 50 years from now, 100 years from now, which is something we've been working on in California. And interestingly, if we go back to 7 or 8,000 years ago, sea level had risen rapidly up until that point. Then it leveled off. And that's the time when the last, say, 8,000 years, when civilization began to develop, when you can see on the bottom here, agriculture, animal domestication. So what that stabilization did was allow these fertile coastal plains and deltas to be inhabited. Little sort of primitive settlements became villages because they could begin to farm, and they moved away from, hunting and gathering to agriculture. So that was a big sort of step in human evolution. Why has climate changed so much? So mostly that's due to the amount of heat we get from the sun. There are sunspots and cycles, but those are very short term. But there's three major cycles that determine how much heat we get from the sun. So on the bottom, there's this 26,000 year wobble. Above that is the 4,000, 41,000 year tilt. So we know the Earth has a tilt on its axis, and that changes over about 2.5 degrees. So it moves us a little, tips us a little further from the sun, brings us a little closer over about 41,000 years. And then our orbit around the sun is not a circle, but an ellipse. And that has a cycle of about 100,000 years. So we put all those together. When they're working together, it gets a little bit warmer than normal. When they're in opposition, it may be less than that. And why do we have that pattern? Uh, the strongest hypothesis we have is that the Earth formed about 4.5 billion years ago. And when it was still molten, maybe 100 million years later, we believe that the Earth was hit by a primitive, also somewhat hot planet about the size of Mars. And that did a number of things. It threw the Earth off its vertical axis and gave us this tilt. It gave us the wobble, and it gave us that eccentric orbit. So that produces the climate changes, the glacial periods we still see. If we go back again, in this case, about 18,000 years ago, um, you can see where sea level was, or the shoreline was, off here at the Farallones. So the last ice age ended because of those cycles of the Earth and the sun. It started to get warmer gradually. Ice melted, ocean water warmed, so sea level rose. Farallones got left as islands, and it entered the Golden Gate maybe 9 or 10,000 years ago. Sea level went all the way to Sacramento. That was the ocean 3 or 4,000 years ago. Sedimentation, some of that from the gold rush and mining, hydraulic mining, some of it artificial fill has um, added to the bay margins. The bay is smaller. But what's interesting is sea level rise doesn't impact just the shoreline. Sacramento is 100 miles from the coast, but it is a port. So ocean-going ships go all the way to Sacramento. So it affects the future sea level rise. Go quite a ways inland. We've been measuring sea level rise for about 150 years from tide gauges. We have one at the Golden Gate and a couple inside the bay. But those measure what sea level is doing relative to land. Um, Land can be going up, can be going down, can be staying the same. So that's relative. 1993, we launched a satellite and then a couple of others over time, and they are measuring sea level rise from space very, very precisely. Um, and we can see that the rate of sea level rise is increasing from maybe 2000 to 2008. It was about 3 millimeters a year. The last decade, about 3.8, or roughly 15 inches per century. Um, so we have to know, and this is astounding to me, we have to know where those satellites are relative to the ground, relative to the other satellites within a hundredth of a millimeter, because they're sending radar beams, gazillions of those, down to the ocean surface, bouncing back, so they can tell that distance and average it over the entire planet. But while we spend a lot of time and effort trying to document future sea level rise, where is it going to be? And again, California's had 3 studies of that. Um, about every 5 years, we're trying to update that. Sea level rise is not our short-term issue. If we looked at those last 10 years, 3.8 millimeters per year is about the thickness of 2 nickels. That's going to get us in the long run, maybe 2075, 2080, and after. But right now, it's the short-term extreme events. So sea level rise has risen, again, gone up and down hundreds of feet, fluctuations over hundreds of thousands of years. But interesting, our natural environments are mangroves, which live in the tropics, coral reefs in the tropics, seagrasses. They have adjusted well to those natural conditions. We worry a lot about those. What's our wetlands going to do? What are our coral reefs going to do? They have responded. They've adapted to climate change really well. What hasn't adapted is cities because we've never had to deal with it before. The last 50, 60, 70 years is where we begin to feel it. So most of our big cities were built on the shoreline. We had access to the water for trade and commerce and navies and so forth. So maybe, and these are hard numbers to get, maybe 150 million people around the planet live within a meter or 3 feet of high tide. 13 million people in the US live within 6 feet of high tide. In the short term, we have storm surges along the California coast and hurricanes elsewhere. During Katrina, that hit New Orleans, storm surges went up to 25 feet above sea level. So that's much, much greater than, 4 millimeters of sea level rise. Um, Gradually, however, that's encroaching. And what we are seeing today is also these king tides, which are the very high tides of the year. Um, and two things are happening as climate changes. One is these low-lying areas are getting increasingly flooded, which will be followed by permanent inundation. And as you may know, this is just after the Golden Gate Bridge where you're starting up Highway 1 and going off to Mill Valley or whatever. So this isn't a flood from rainfall. This is high tide. This is ocean water. Um, the other thing that's happening with higher sea level, and we know waves are getting larger, is higher sea level brings the storm and the waves closer to the coastline or the shoreline or the cliffs. So those waves are eating away at the cliffs and bluffs. And we'll talk a little more about Pacifica, but that's sort of uh, an example of the worst that can happen, and that's continuing. Uh, So I mentioned that we have tide gauges. This is one at the Golden Gate. This was put in back in 1855 or so. Originally, tide gauges were installed so that ships coming in and out would know, you know, where the high tide and the low tide would be, how much depth they had to the bottom. But what we have discovered over time um, is that sea level is rising. That's not why they were put in place, but that's what they have told us. So you can see this gradual rise, about 2 millimeters a year, averaged over the last 175 years or so. That's equivalent to 8 inches per century. But again, this is relative because it's set on rock near the Golden Gate, and if sea level is doing one thing, but the land can be doing something else. So this is um, maybe a little bit lower than the global average because maybe the land is being uplifted. But within this pattern, we can see these peaks, one around 1940, one around 1982, 83, one in 97, 98. Those are El Nino events, which all the data is indicating we're up for a big one this coming winter. Um, that's a whole nother story. But what it does do with this warm water that comes across the Pacific and hits the coast off Peru and Ecuador, it begins to move north along our coast. So sea level rises. It may be, in this case, 30 centimeters or 12 inches higher for weeks on end. So compared to that slow sea level rise, um, it's a lot greater. This was an 83 El Nino, one of the biggest on records. And it's interesting to look in well, if we look at four tide gauges along the California coast, San Diego, Los Angeles, Monterey, San Francisco, we can predict the tide centuries in advance because it mostly has to do with where we are relative to the moon and the sun. Those are the big atmosphere, or the planetary bodies that pull on the oceans due to gravity. The moon being about twice as important because it's much closer. So these are the predicted tides. These are the actual tides recorded because of that El Nino. So this is the difference. So in Los Angeles, it was about a foot higher than expected. In Monterey, it was about a foot and a half. In San Francisco, close to 2 feet higher than predicted. So those are these short-term events. If we get big waves on top of that, that's when most of the damage occurs. So almost exactly 40 years after January 1983, we had another really big winter. And this is the coast of Santa Cruz. We may know West Cliff Drive. We just lived 2 blocks in there. I could kind of hear and feel this. The ocean was, I'm going to say, as angry as I've ever seen it. So a couple things coincided here. We had really big waves. An offshore wave buoy measured those as 28 feet. And we had really high tides, about a foot higher than predicted. So those two came together at exactly the same time on the morning of January 5th. And that continued for a while longer. And then the next winter, later, December of 23, and then 2024, we've had three major winters in a row with high tides and big waves. So this is going to be much more problematic than 4 millimeters, 2 nickels worth of sea level rise. So I'm going to call it an extreme event short term. This is down near Ventura, and I'm always trying to determine what this lady is doing. I'm not sure. Maybe she'd want her glass doors to break. Um, but looking in the bay, this is Capitola. Maybe many of you have been here. It was built really on the sand. It's on the back, or I should say, the front of the beach. And it's also on the delta of Soquel Creek. So they have been hit repeatedly. It's a great summer vacation spot. People love this little village. Um, but this is the waterfront, the Esplanade. And they built a seawall there some years ago because they got flooded so often. And then there's these walkways where you can go through the wall and they actually drop planks in there when they expect a high tide. So That's on a nice sunny day. People are having their lattes out there and reading their Wall Street journals. And then a few months later, this is happening. So a king tide, big wave goes over the wall and right into downtown. This is one of the restaurants there along the Esplanade. The pier was damaged. Some of the beams from the pier came into the restaurant. And this is where Joe Biden even came out to look at the restaurants and say, we're going to help you build back. Sadly, in a way, Capitol is built back again and again and again. We've had maybe 15 major storms like this over the last 150 years, and Capitola just keeps coming back. Not sure how much longer they can do that. If we look down the coast, a couple of miles along the shoreline of northern Monterey Bay, we have Rio del Mar. And in 1929, we had really wide beach here. The beach was so wide, there were dunes at the back of the beach that were vegetated. So some enterprising people uh, must have surveyed at the time. And if mean high tide is sort of the dividing line between public property, the state owns everything below mean high tide, and people, individuals can own above high tide. So somebody claimed this, built roads out on the beach, and then subdivided this. This is called the island. These are all now covered with homes, and you can see today. But they're basically built on the back beach. They're built on sand, and you don't have to have a mind like, well, I don't know why we call a physicist or a marine biologist, but if you're built on sand, it got there because of wave action. So if you look at Rio Del Mar and Beach Drive today, all those homes were built on the sand, and they have repeatedly been flooded with high tides coming over the seawall. That 2023 winter, we had logs and debris carried up over the wall, and this one came pretty close to going through people's windows and doors. They actually have a second seawall in front of many of those houses. Sea Cliff State Beach is another place that was state park built on the sand. They have both picnicking, parking, restrooms, and also a place for recreational vehicles. That timber bulkhead, and this first went in a century ago, has been built and destroyed 8 times. Again in 2023. The timber was broken down, the fill was removed, the parking area was destroyed. So they hired a consultant to come in. We talked to them ahead of time and said, this is a recurring problem. They actually decided they're not going to rebuild this for RVs, but any RV camping will be up on the bluff, but there'll still be a place where people can drive down, park, get on the beach. Closer to home, SFO was built about a century ago, actually on what was a cow pasture. It was very low-lying. At the time, back in the 20s and the 30s, they weren't worried about sea level rise, so they brought in fill from the surrounding mountains. So they got about 2 feet above high tide and said, we're good. This is what it looked like when it opened. It was called Mills Field. Now it's, a massive international airport. But what happens in the future with SFO? And they are very concerned about this. There's a wonderful site put out by Climate Central called Surging Seas. You can go anywhere in the US and click on it, and you can get the current coastline. And then you can add 1 foot of sea level rise above the highest tides. So this is SFO on the lower left, and you can see part of the runways go underwater with 1 foot above highest tide today. Oakland Airport is over here. The green are areas that are below that elevation, but there's some barrier. Maybe it's a seawall or a highway or a berm. So we can go up to 2 feet. Actually, this is 3 feet, and SFO is completely underwater, the runways. Oakland is underwater, and the waterfront begins to get wet. And 5 feet, things start to change. That's the Alameda Naval Air Station. So 5 feet is possible by 2100. The general average or mean value might be 3 feet, which we could see what 3 feet does. So that's 75, 74 years away. Um, because the economic value of SFO, they have been planning for a 10-mile long, $587 million seawall. Um, Try to protect it till at least maybe 2075. They're now doing the environmental impact report on what that seawall would do. Um, is that price going to still be the case by the, I think it would be done if they built it by the mid 2030s. But here's what one community or one facility is doing. Pacifica, um, up in San Mateo County. Um, this is an aerial photo, the first aerial photo of the California coast taken in 1928. And Laguna Salada is a feature you can still see. There's actually a golf course out here too. But what you can see at that time, Maury Point sort of acts like it's a headland. It acts like a natural groin or barrier. So it traps sand moving south, and you can see a really wide beach, the beach and the dunes extending inland, a lot of sand dunes moving inland here. So all of this was shoreline. But over time, Pacific has encroached on that shoreline. So here's Laguna Salada again, going backwards. So this whole waterfront area was built out on the beach. They've encroached further and further onto the shoreline. This is looking from Maury Point down. And the beach actually gets narrower off in the distance by the pier because, again, they built out on the shoreline. Um, they've had a series of seawalls that have been battered um, because they've encroached onto the natural shoreline. So the beach would rather be inland. Seawall has been undermined and collapsed. Um, they're still trying to figure out how to deal with that. And what's interesting is we've developed what we could call a perched beach. So the waves are carrying this gravel over the seawall, across the walkway, across the road, and into people's yards. There's a nice caution here. Um, so these people are shoveling the beach gravel off their driveways, and some of them have put up boards. So encroachment on the shoreline is clearly a problem. They've got a little barrier here trying to keep the gravel from going into their garage. So a problem area because of the way they've developed. So human encroachment is a problem. Half Moon Bay has this great name. It's shaped like a perfect half moon. Um, and we have a number of these, what have been called, half moon shaped bays or fish hook shaped bays, or actually it's a log spiral. That what happens when we have a very resistant headland like Pilar Point, and as waves hit that headland, and if there's weaker materials behind it, the waves will gradually erode into those weaker materials and produce this perfect equilibrium shoreline. So back in the 50s, well, actually in the 70s, I guess, 60s, 70s, Half Moon Bay decided they wanted a harbor, so the Corps of Engineers built a breakwater. Actually built in 1959, I'm sorry, for boats. So here was the breakwater. What happened was the wave energy that was being sort of dissipated in the lee of that headland now came down the breakwater and hit the coast right here. So the shoreline there is not rock, not like Pilar Point. It's a very low, very erodible coastal terrace. So that area accelerated from virtually stable to feet per year. Um, this was taken in 1973. I was up there, and you can see there was a road along here that's been uh, undercut and eroded. They threw in a few rocks and broken pieces of concrete. The waves went right over it. This is 1976. There's the old Ocean Shore Road. This is the access to the sewer line was under the road there. That was eroded. Um, One of the books I did a few years ago, I use that as an example of some of the problems of living with an eroding coastline. So as you go down, the coastline has continued to erode quite a ways down. Coast from the end of the breakwater, they put in a lot of rocks. There's a bridge here that was destroyed, they had to replace. Um, one, I guess these are, I'm not sure it's an apartment or a condominium they've had to protect, and you can see they've had a wall here that's gone. These townhouses are worried, and you can see that road. I'm sorry, the bluff continues to erode. The pathway is now eroding. So, continual erosion from that breakwater down coast because of disturbing the equilibrium. This was the new bridge they put that was sort of a uh, pre-built bridge. In Pacifica, again during the 1983 El Nino, really big waves at times of really high tides, and you can see this isn't rock, but it's just dirt. So they actually removed some of those mobile homes. That three-story building was moved back. 1983 El Nino, they actually put in a riprap armor here that by the 1997 El Nino had completely been removed, and this whole row of houses was now taken out. There was three houses left. Those have now been taken away. Back in the 70s, there was a series of apartments built in that area. But you can see this isn't bedrock. It's very weak soil and sediment that's very erodible. Nonetheless, this is pre-coastal commission. They built these apartments. Um, Erosion continued. 2004, 2009, they're getting close to the edge. They threw in some riprap. By 2010, they were right at the edge. The homeowners had bought and sold, or the owners, and they're now trying to uh, drill back into the cliff, put in some soil nails and some concrete, which really didn't work. A few years later, that was gone, and these were declared unsafe to occupy, and they were gradually demolished, and as well as some houses. And just a reminder that the Pacific Ocean is 8,000 miles wide, and it doesn't care too much about a few feet on either side, but have built in many cases right to the edge. So there's the foundations of those apartments, and they're still trying to protect that. So where do we go? What's next? Whether it's global climate change or sea level, we really have three options. One's mitigation, one's adaptation and suffering. So we can mitigate by going to renewable energy, which we should be doing. And under this administration, we're doing exactly the opposite, but solar and wind. So that's been slowed down. We can adapt like they've done in Sausalito, but the world's population isn't going to all be able to live in houseboats. And we can suffer. We've suffered fires and floods, sea level rise, among other things. There's a few responses to coastal retreat. We know what they are. Denial. We can put more sand on the beach. We can build armor. It's a push now for living shorelines or nature-based solutions, which has some limitations. In the long run, there's one solution. We're going to have to move back. So denial, short term, doesn't work very well when something happens. Nourishment is very expensive and short-lived. This is what the East Coast has done, not much in California. We did a couple of big projects in San Diego, spent $46 million, and that sand was gone in 1 to 2 years. Armor, California, about 14% of the entire California coast has been armored. Most of that in Southern California, where 38% has had some type of structure, but those structures have impacts. Um, all protection ends somewhere. We can't build walls forever. We can only build them so high, and then we're going to have to do something else. Push today for living shorelines, nature-based solutions, which sound great if it's green. We love it. Mangroves, coral reefs do pretty well. They only are common in tropical environments, and we are not a tropical environment. Various kinds of seagrasses are good in low energy environments, but that's not what we have on the outer coast. West Cliff is not a place for living shorelines. And we've done sort of dune vegetation, but when a big storm or hurricane comes, this does not stop the ocean. And there's now companies making money building these sort of artificial structures that are supposed to mimic reefs and then hoping things grow on those. Basically, they're seawalls, but they will have their limits. So At some point in the future, depending on which location, it'll be either managed retreat, and we can move some pretty big structures back. We cannot move San Francisco. We cannot move Miami, um, or unmanaged retreat. So we look at the Embarcadero and say, what are we going to do here? Here are plans for a major seawall. What about Miami? I don't think so. So I'm going to stop there, and I hope we got some time for questions. Thank you.
Awesome. All right. Thank you so much. There's a couple of questions that are coming in here. This is a great time if you have some questions based on what we've just heard. I'll start with John's question. He was saying because of the salt content in the oceans, which he's guessing is variable per specific ocean sea, does it take longer for a sea or ocean to freeze?
Yeah, it's harder to freeze seawater. The salt makes that complicated. What we do when we freeze it is we actually push the salt out. So where we're forming sea ice, we actually have fresh, the ice is fresh, but we have saltier water around it. And it turns out it's a way we can desalt seawater, but it's not very effective because we end up with this slush, versus, say, distillation where we boil it, we leave all the salt behind, or now we use reverse osmosis and push it through a membrane.
Second question is also from John asking, speaking of the Earth tilt, does the tilt affect how sea level rise might impact one continent over another gravitationally?
Interesting question. Um, Not really. It's more sort of where we are in terms of shoreline configuration. So, for example, and what latitude we might be at. So, for example, um, the coast here, central Northern California, our total tidal range may be 9 feet, changing during the tidal cycle. If we go to the Gulf of California, because it's this long embayment, tidal range might be 20 feet. And in the Bay of Fundy, Nova Scotia, it's about 45 feet. So different places on the planet, depending more on their latitude and the coastal configuration, will have a greater or lesser tidal um, uh, level. And if we go to Hawaii in the middle of the ocean, the tides are like a big wave that sloshes back and forth across the Pacific. So we see it at the edges, but the tidal range in Hawaii is very low because it's out in the middle of the ocean.
Lauren asks, let's see, if the political will and resources actually existed, what would be the best case scenario approach for managing, oh gosh, we have so many of these coming in, it's coming through, for managing sea level rise in San Francisco, which is too big to shift, or a smaller spot like Pacifica where maybe more could be moved?
Yeah, really good question. And the question is framed perfectly correctly. Right now, we're doing exactly the wrong thing under this administration. Let's not mince words or, canceling uh, offshore wind farms, including two off California, and taking our money to buy those back from the companies that bid to put them in. This administration is going to be gone. We're just going to have to suffer in the meantime. The real difficulty is because we've been putting greenhouse gases, the big ones are carbon dioxide, which is now about 50% higher than it was pre-industrial times, and methane, where we've put so much of that in the atmosphere. um, it's going to take centuries for that to equilibrate. So we can begin to slow it down, but no matter what we do, sea level is going to continue to rise. The planet's going to continue warming for probably centuries. So one thing we don't want to do, I guess, is we don't want to build any more, say, sort of high value public infrastructure where it's going to be impacted by sea level rise. How much do we plan for? We could have another eight. Well, by 2100, by 2050, our best estimate is about a foot higher. We can live with that. That's a really high tide today. By 2100, the midpoint of our calculations is about 3 feet, but it could easily be 6 feet or higher So whether it's a wastewater treatment plant or a desal plant or a highway or a bridge, we don't want to be building any high value infrastructure within a range that we know it's going to be inundated in, say, 50 years. We can move other things back and we're going to have to, but I think that's a giant challenge that the world has never had to face before. What do we do with these cities? And you can see them around the planet um, that are, simplest way to put it, they're in harm's way, and we can't stop sea level rise anytime soon. Part of that with the climate is also we're creating bigger waves, the warmer ocean, more evaporation, stronger winds, and it's the winds that create the waves. So we have some major challenges, and I'm going to say boldly that sea level rise is going to be the biggest challenge in our lifetimes that human civilization has ever had to face. You know, COVID's going to be gone, this president's going to be gone, but sea level is going to rise for a long time to come. And
Mhm.
that's not something you want to tell young people, but we need to be honest about that.
Yeah. Um, do you have any, is there anyone you could speak to when you're thinking about other nations that are not in as much denial about some strategic retreat that, we could model ourselves after, or just that you're seeing as being really significant?
Every other nation. So interestingly, we now have in the US, I mean, we're doing well on solar on land, and we've been doing pretty well on wind on land. Um, we have exactly 7 offshore wind turbines. Northern Europe has 5,000. So they are making really wise decisions. I think they have more enlightened leaders. China is now going gangbusters on, they're the major manufacturer of solar panels that we are putting a tariff on. But they are building lots of wind farms and solar panels. They're also making a lot of concrete, which is a major contributor to carbon dioxide in the atmosphere. So I would say virtually any other country in the world is doing better than we are and looking for the future. We also are number 2 in the world in terms of carbon dioxide production from burning coal, oil, and natural gas. And again, this president's trying to open up closed coal mines that aren't efficient and removing some of the air pollution standards. So everything's going in the wrong direction. That's going to have a big effect on all of us and our children and grandchildren, unfortunately. This is
Mhm.
sounding depressing, isn't it?
Yeah. Um, well, there's another question, but I'll get to this one. So someone was asking about Pillar Point Harbor specifically. I don't know if you're familiar with the dredging that's happening in Pillar Point Harbor, that there was a test that was done, but do you see this as a viable long-term solution? Um,
What, keeping harbors open and dredging them?
yeah, so there, Pillar Point Harbor, do you think this is a long-term viable solution to approximate natural sand migration blocked by the jetty?
Well, it's an equilibrium now. I mean, what's coming into the harbor, and actually that's in a much better situation than many of California's harbors, say Santa Cruz, Santa Barbara, Channel Islands, Ventura, because of the shape of that breakwater. Most of the sand actually moves further down coast, so the little bit that comes out of there is coming out of the few streams and stuff that come in there. So Pillar Point Harbor is actually the bigger problem is what's happening down coast with erosion. But at Santa Cruz, we dredge out 300,000 cubic yards a year. That's 30,000 dump truck loads because of where we place these harbors. So one problem in the future will be with sea level continually rising, what does 3 feet of sea level rise do for those harbors? And boat slips are normally they float, so they rise up and down with the tide. So depending on how much future sea level rise they were planned for, I think our harbors are going to last for a while longer. Um, I guess in some ways for harbors, it's better to have sea level rising rather than sea level falling, where pretty soon the harbors would have to be dredged to greater depths. But we're okay on that regard for a while.
Mhm. Um, is there anyone, this is a little bit of spin-off of what you were asking before, but what is the best example you've seen worldwide for dealing with sea level rise in coastal urban environment, or one of?
Mm. Um, There's a great example on the Yorkshire coast of England, which is sort of the southeastern coast of England, and it's in very erodible glacial sediments. Um, that coast has been retreating at about 6 meters per year for since the time of the Romans for 2,000 years. And I did a book a couple of years ago called Coast in Crisis, and I wanted to see other coasts besides California, so we spent a month driving around the coast of England, Scotland, then a month around the coast of Spain and Portugal. So we went to the Yorkshire coast of England. And rather than big cities and development, mainly it's cow pastures and fields, but they actually have put in I don't know, I think we counted 10 or 15 what they call caravan parks. So they're for um, mobile homes, manufactured homes, both those that people can come in and vacation, but even those that people live in or have for vacation homes. Um, Everybody gets a concrete pad and a water and a sewer and electrical hookup. And you can see on Google Earth, if you go to the Yorkshire coast is retreating at 6 feet per year. You can see it failing. And when the coast gets close to your trailer, you just hook up a truck and you move to the back of the line, and somebody else gets an oceanfront site for 5 or 10 years. So that's what I would call resilient. You're actually responding in a very sensible way. They're expecting that and they plan for it. We do have some mobile home parks in California on the coast. I showed that one in Pacifica. There's one in Santa Cruz. There's one down at San Juan Capistrano. Um, so you can move structures back. I think the problem is most of our coastal land is so valuable that nobody's planning on moving. And this is where we are in California today with the issue of managed retreat, that the Coastal Commission has requested that each coastal city and county in their local coastal program revision that they include how they're going to deal with sea level rise and managed retreat. Um, it's really difficult. Most people say, no, we're not going to retreat. I'll retreat if somebody buys my house. And you have places like Malibu where houses are 10, 20, $30,000. We could never afford to buy out those houses. So I think it's going to be a pretty exciting time, maybe 10, 20, 30 years from now, because we can only build walls so high. We can only build them so long, and then we're going to get them overtopped or outflanked. So I wish I could be here in 100 years to see what happens. I don't think that's going to happen, but a few places like England and the sort of Mediterranean coast of Spain and Portugal, France, and even Japan have built really massive walls, 20, 30 feet high, something like the O'Shaughnessy Wall in San Francisco that could last longer. But at some point, maybe it's 150 years from now, they will likely be overtopped. And that's when things are going to get really difficult.
Mhm. Ginny's asking about, do you know anything about green horizontal levees in the San Francisco Bay? What would your thoughts be on that?
Yeah, they planned those on the east side of the bay to deal with, sort of these mud flats and wetlands. Um, well, there's absolutely nothing we can do over the long run to hold back the Pacific Ocean. So it depends on what we call the long run. Is that 20 years, 50 years? Anything we do is a band-aid. And those band-aids come in different sizes, different prices, and different, lifetimes. So we can build horizontal levees that might be 3 or 4 or 5 feet above today, sea level. But at some point in the future, they're going to be overtopped, just like our seawalls, just like the picture in this slide here. So they're all short term, and it just depends on what that term is, because the San Francisco is surrounded by development. At some point, let's just say 6 feet above high tide, and then some storm, the waves will go over that horizontal levee. So I think they can be effective in very low energy environments, but they're effective only for a certain period of time. But I guess we can see that about everything. Our cars only last a certain period of time. Our highways only last a certain period of time. Hopefully we get through our lifetime and it's still working.
Mhm. And this is a slight tangent, but this comes from Petra, what projections are there regarding the impacts of sea level rise and ocean temp changes on the global ocean currents? And I know the temperature part, but what about sea level rise and impact of global ocean current?
Um, yeah, I mean, ocean currents are really important in controlling coastal climate. I don't think sea level rise is going to have a big effect. Again, think about 2 nickels a year, minor compared to temperature changes. So the one we hear about now is been referred to as AMOC, or Atlantic Meridional Overturning Currents. So we know there's a sort of a path that the currents take around the ocean. And in the Atlantic, for example, we've got warm water. Same thing happens in the Pacific. The trade winds blow warm water from the eastern Atlantic or eastern Pacific across to the opposite side. So in the Atlantic, they come into the Caribbean, it turns into the Florida current, and then the Gulf Stream that goes along the coast of the Atlantic coast of the US and then out across the Atlantic to warm up northern Europe. So we have, for example, the latitude of Spain, which is pretty warm, is the same as the latitude of Maine, which is pretty cold because of those currents. So what's happening is the ocean gets warmer, more ice melts. We're sort of disrupting rising and sinking in transport. So there's real concern that we're starting to affect what's happening in the Atlantic. A little different down the Pacific. The Pacific is much bigger. We do have the corresponding Kuroshio current, the Kuroshio extension, the North Pacific drift, and then the California current, cold current that comes down our coast. Um, I think those changes on our coast are going to be pretty minor, but in the Atlantic, they're beginning to worry about it.
Great. Um, Keith asks a question about data available on local wave power increases, and Keith will attach that to a follow-up email that we'll be sending your way. Just one more question as you're talking about in 100 years, you'd love to see where we are, sort of through the lens of what if we get it right? If you were to, if the best case scenario, given what will have occurred, what we will have done, um, between now and then, and what would that look like? What will have been done between now and 100 years ago, 100 years from now, when you're standing there looking, what does that look like to you? What will we have done and where will we be?
Well, I'm honored that people have the confidence in me to say what it's going to look like. So again, that website that I showed you with the sea level rise in San Francisco Bay, uh, Climate Central, uh, and you can see where the shoreline will be with 1 foot of sea level rise, 2 foot, 3 foot. And you can also do by year. You can go 2030, 2050, 2100. Those are using, um, and the subsite is called Surging Seas. Um, those are based on our most accurate land elevations. And those aren't going to change a lot in the near future. So I think what they do show, I mean, you can say, well, it's going to rise a foot in here in San Francisco. The picture that's still on the screen, at least on my screen, is this guy in a wheelchair out on the Embarcadero. Um, I think a lot of people don't realize how close they might be to sea level. So you put in 3 feet or 4 feet or 5 feet and go, whoa, we're underwater. So, and then that map I showed, which is with 218 feet of sea level. So some areas are going to be inundated. There's no question about it. Um, Again, even along the Sacramento River and the paths that ships take all the way up to Sacramento, most of those levees weren't really engineered for today's standards and sea level rise. Those are sort of going to be compromised. We look at places like, I'll go to Southern California, there's a lot of low-lying coastal land. Um, Balboa Island, Newport Bay, Long Beach, Naples, Long Beach Peninsula, Belmont Shores, those are all within a couple of feet of sea level. And those are billions of dollars worth of homes. So in some ways, the cliffed areas of San Mateo County, much of Santa Cruz County, are much better off. Maybe wave energy increase a little bit and coastal erosion, but most places coastal erosion is maybe a foot per year, maybe
Mm.
less. Southern Monterey Bay, it's 4 or 5 feet because it's sand dunes. Those are the weaker areas. So I think we can look, we're actually working on a project now to put together an online digital coastal hazard atlas for California, trying to look at every coastal city and county and see, can you look into the future sea level rise? What's the rate of retreat now? Where is it going to get flooded? But I mean, those are a really good question. Um, and I mean, that's the best answers I can give is kind of projecting what the past has been like into the future and then beginning to accelerate that.
Well, it speaks to, I think what you're saying makes a lot of sense, right? Is that, or what I think I'm hearing from you is that we need to dial in what does managed retreat look like, right? And there's so many different lenses that you're coming at this from. This is what we know from a geologic perspective. This is what we know from, looking at these projections over time. There are going to be these other infrastructure people who are coming in with the expertise from the infrastructure perspective. I'm seeing a couple of things in the chat about, well, where would we move, sewage treatment plants and how different ideas that people have. But like, I think true part of that is like we're all bringing these different skills with the idea that there is urgency in the time scale here to figure out how to manage this. Otherwise, it is going to just have to be it is happening whether we are these micro levels are not enough. We've got to come up with some bigger management plans and recognize the threats for sure.
Put that really clearly. And I think the thing to keep in mind when we mention sea level, when we mention ocean temperatures increasing, how that affects organisms around the planet that are in the water, like coral reefs, oceans getting more acidic, atmosphere got more carbon dioxide. There's some plans underway that's called carbon dioxide removal. Can we
Mhm.
take carbon dioxide out of the atmosphere? Can we take carbon dioxide out of the ocean? Trees do that, plants do that, kelp does it, and things are in balance. The problem is if you look at the oceans of the world, just stand on the coast and look out there or fly to Japan or fly to Europe, there's 330 million cubic miles of seawater. Just try to imagine what it would be like and what it would cost to take the carbon dioxide out of the sea, out of the ocean. The atmosphere goes up 20, 30 miles, and people have some firms have developed some systems to take it out. It is so incredibly expensive, and there's so much up there. It's a lot easier, much easier to quit putting it in to begin with, and that is eliminating our use of coal and oil and natural gas. So we quit putting it in the atmosphere because we can't even keep up with what we're putting in, not trying to suck it out of the atmosphere and suck it out of the ocean. But you're right, different perspectives provide, and there's the human perspective, what are people willing to sacrifice to, well, we don't need to sacrifice. We can do smart things, and that's happening around the world despite, I'm going to say the T word, Trump and what he's doing.
Well, and it's wonderful to see when I look at this, the more than 250 people have registered for this webinar. So it's 250 different brains of people who are coming at this to gain information. And hopefully each of us is kind of making some thoughts about how can we, if we are really honest about this information, what are the skills? Who are the people we connect with? What are the different policies that we need to get behind, projects that we need to get behind?
Right.
Never mind the on the ground local work that's being done.
Yeah. I often get asked at the end of a talk, because people are concerned to see the students in my classes, what can I do?
Mhm,
And I
mhm,
say there's something everybody can do that matters more than anything, and it doesn't cost you anything. Vote.
mhm, mhm.
Thank you for asking me to speak. I hope this was worthwhile for everybody.
We're so grateful, yeah, to have you here. And thank you all for being here on a Saturday morning, or whether you're receiving this as a recording and taking time to listen to this. I have a feeling if you've started at the beginning, you'll probably stick to the end because they're really interesting conversations and really so much to learn. Yeah, thank you all for being here. Thank you, Dr. Griggs, for making this time on your Saturday to speak with everybody in our community.
My
If
pleasure.
Thank you. If you are left with questions or you want to catch some of these links, we didn't get to. I was thinking you were going to share some of your books, so I saw those on slides, but now you're sharing. So we're going to share. Like these are all such. There are some incredible books in here. Um, And do you want to speak quickly to, I actually have a number of these books and have been using them in curriculum, but do you want to share your newest book, just quickly, a little bit about the newest book that you, it's,
Yeah, it's the one on the right, California Catastrophes, the Natural Disaster History of the Golden State. And I was just trying to go back in time and look at, because we often think of, understandably, our own lifetime, but people have what I call disaster amnesia or a short disaster memory. You know, we have a earthquake or a flood or a fire, and we want to go back, and this is happening with the areas that were burned. We want to go back and build our house as quickly as we can. You know, there's a storm, we want to rebuild Capitola. That may not be the right thing to do, and I think we need this a little bit longer term perspective, a little bit maybe in California, 150 years of events. So that's what I tried to capture with floods and landslides and coastal erosion and earthquakes and landslides and tsunamis. You know, what do we know? What's happened? So let's not make the same mistake again. The one on the left is about the whole California coast, and we go county by county down the coast and look at what we know about erosion and damage. And um, Coast and Crisis is a global book about not only the challenges, natural effects, but what we have done in terms of pollution and oil drilling and coral reefs. And The Edge is done with a friend, kind of a more personal book. Our experience on the coast and what we've learned about how the coast is changing and the vulnerable areas. And these are two more descriptive books. One part of the University of California Natural History Guide on the left. The other, if you don't know about it, it's this incredible site called California Coastal Records Project. Um, this couple, Ken and Gabrielle Edelman, have flown the entire California coast in a helicopter, taking pictures overlapping the whole coast since 2002 up to 2024, maybe 8 or 10 different flights. I had some earlier photos that were taken back in the 70s, so we now have over 50 years of record, and you can go on that site and you can just sort of fly down the coast and blow up these pictures and see uh, everything, incredible detail. So we put maybe, I don't know, 100 of the best ones together in this book and published it, which I love because I think that looking at the coast, there's the natural and the unnatural, the developed, and it really shows up clearly. So thank you for that, Kate.
yeah, and we'll link those on the follow-up email, everyone. So if you're curious in how you can get these, we'll link those in a preferred place to purchase those as well. All right, thank you very much. If it is within your bandwidth to make a donation to the Coastside Land Trust, we will greatly appreciate that so that we can continue to host these webinars and help to educate you and connect you with the natural world here. And we hope that we will see many of you in our upcoming we have a Habitat Heroes along the coast on the second Saturday of every month. If you'd like to get involved in that, please reach out at info@coastsidelandtrust.org, give you some information on that. Lots of things coming up, so check out our website and our social media feeds, and we'll connect you with that. But again, thank you so much, and thank you again, Dr. Griggs.
Okay,
Bye-bye.
bye.